The sides of a right triangle have special names. The legs are the two sides that form the right angle. The hypotenuse is the side opposite the right angle. Of the three sides, the hypotenuse will always be the largest. In any right triangle, the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. Or, said a little bit differently, if the legs have lengths of a and b, and the hypotenuse has length of c, then we know that a squared plus b squared is equal to c squared. A Pythagorean triple is a set of three numbers, a, b, and c, being where the c is the largest, such that a squared plus b squared is equal to c squared. So let's verify that each of the following make up a Pythagorean triple. So 3, 4, 5. Well, 3 squared plus 4 squared would be 3 squared is 9. 4 squared is 4 times 4 is 16. So 9 plus 16 is 25. 5 squared is also 25. So in this case, 3 squared plus 4 squared is equal to 5 squared. That means 3, 4, 5 is a Pythagorean triple. If I go 8 squared plus 15 squared, that would be 64 plus 225. If you add those together, that's 289. 17 squared, 17 times 17 is also 289. So in this case, 8 squared plus 15 squared is equal to 17 squared. So 8, 15, 17 is also a Pythagorean triple. All right, so let's find the length of the hypotenuse of this triangle. So we have, that looks like the legs are 5 and 12. The hypotenuse is a c. So we have 5 squared plus 12 squared is equal to c squared. 5 squared is 25 plus 12 times 12 is 144. 25 plus 144 is 169. So take the square root, you'll have c is equal to 13 meters. So the length of the hypotenuse is 13. The Pythagorean theorem can be used to derive a formula for the distance between any two points in a coordinate plane. So the distance d between any two points, so say we start with this x1, y1, and we want to find the distance to x2, y2. What we do is we can form a right triangle in terms of the horizontal and vertical components. The horizontal component is the difference between the two x values, x2 minus x1. The vertical component is the difference between the y values, so y2 minus y1. And then d would be the hypotenuse, is also the distance between the 2 points. So what we have here is that d squared is equal to this x2 minus x1 squared plus y2 minus y1 squared. And then if you do the square root, you have the distance formula. The distance is the square root of the x2 minus x1 squared plus y2 minus y1 squared. So say I want to find the distance shown here. And what I want to do is, you can think of forming a triangle. So this length right here, the horizontal part is length of 3. The vertical part has a length of 2. And then my hypotenuse is that distance. So what I know is that d squared is going to be that 3 squared plus 2 squared. So the distance is going to be 9 plus 4, or 13. Or d squared is 9 plus 4 equals 13. So the distance between the 2 points is the square root of 13. And you can put that in the calculator to get an approximation, but that would be the distance between those 2 points. So prove that the triangle with vertices at 1, 4, 5, 0, and 7, 6 is isosceles. So that is, show that the two sides have the triangle have the same length. So let's start with this one right here, between r and t. So the distance would be the square root, difference of the x value. So t has an x value of 7, r has an x value of 1. So I'll go 7 minus 1 squared plus 6 minus 4 squared. So that'd be the square root of 6 squared plus 2 squared. That'd be 36 plus 4. So that'd be the square root of 40. Okay. Let's go on to another side. So let's try this side between R and S. So D would be the square root. Let's see, the x values are 5 and 1. So I go 5 minus 1 squared plus 0 minus 4 squared. So this would be square root. 5 minus 1 squared is 4 squared plus, well, technically negative 4 squared, but the negative is going to disappear by the squaring. So we'll have square root of 16 plus 16. That'd be a square root of 32. Okay, so those two sides are not the same. Let's see how this third side goes. So the x values are 7 and 5. I'll go 7 minus 5 squared. The y values are 6 and 0. So this would be the square root of 2 squared plus 6 squared. That'd be square root of 4 plus 36 is the square root of 40. So between R and T is the square root of 40. Between T and S is the square root of 40. That means that this side and this side are congruent, and this would be an isosceles triangle.